In this example, we want to analyze the graph of the function r of x equals x plus 7 over x times x plus 11. So first, we want to make sure we simplify that rational function so that we cancel out any of the common factors. Luckily, this function is already in factored form for us, so we don't need to change anything. Can't be factored anymore. Then we want to find the domain. We can find the domain by setting the denominator equal to 0 and then setting each factor equal to 0. So we get x equals 0 and x equals negative 11 as our excluded values, and we'll write our set builder notation. X is not allowed to be 0 and x is not allowed to be negative 11. So the domain of this rational function is all real numbers except for 0 and negative 11. We can also write this in interval notation. Negative 11 is excluded, 0 is excluded, but all other real numbers are included as part of the domain. So we want to represent this interval, which would start at negative infinity and go all the way to negative 11. Represent this interval, which goes from negative 11 to 0. And represent this interval, which would go from 0 to infinity. And we'll union those together, and this is the domain in interval notation. And then, as I said earlier, we want to write our function in lowest terms, and this one doesn't have any common factors, so it is already in lowest terms. We want to continue analyzing this function by finding any x and y intercepts. So let's first find a y-intercept. So the way we find a y-intercept is by letting x equal 0. So we're substituting a 0 into our function. That gives me 0 plus 7 over 0 times 0 plus 11. That's 7 over 0 times 11. And that's 7 over 0, which is undefined. So that means we don't have a y-intercept for this function. And then we want to find any x-intercepts. You can find x-intercepts by letting y equal 0, and r of x is the same thing as y, so we're setting our function equal to 0. So this would give me 0 equals x plus 7 over x times x plus 11. To solve this rational equation, I want to cancel out the denominator, and I'll do that by multiplying both sides by the denominator. I'm multiplying the right by x times x plus 11, and the left by x times x plus 11. On the right side, the x's will cancel, and the x plus 11's cancel, leaving me with x plus 7. And on the left, 0 times anything is 0. And so then I'm able to subtract 7 on both sides to get x equals negative 7. So we have an x-intercept of negative 7, 0. And looking closer at the directions here, the directions say to simplify your answer, type integers or fractions so that they don't want ordered pairs. So the graph does not have a y-intercept, but it has an x-intercept of negative 7. So I'm going to use this one right here. No y-intercept, but an x-intercept of negative 7. The next part says determine the behavior of the graph at any x-intercepts. And so we have that x-intercept of -7. And at -7, because x plus 7 is a linear factor, the graph is going to cross at that point. So the graph will cross the x-axis at our x-intercept of -7. The next part says determine the vertical asymptotes. For the vertical asymptote, you want to make sure our function is in lowest terms, which it is, and then we're going to set our denominators equal to 0. So our denominator is x times x plus 11, setting each factor equal to 0. We get x equals 0 and x plus 11 equals 0, x equals 0, and x equals -11. So we're going to have vertical asymptotes at x equals 0 and x equals 11. Continuing to analyze this graph of the function r of x equals x plus 7 over x times x plus 11. The next part says determine the behavior on either side of the vertical asymptote. The definition of a vertical asymptote is that as x is getting closer to that value, the y is either going to go to infinity or -infinity. So when we're determining the behavior of the graph, we just need to figure out whether our y is approaching infinity or -infinity at that vertical asymptote. We've already determined that we have vertical asymptotes at x equals 0 from this factor and x equals -11 at that factor. So we want to figure out the end behavior around those. Not the end behavior, but what the y value is doing. So I'm going to set up a chart here, and I'm going to put the vertical asymptotes as well as the zeros. So that's -11, -7, and 0. And we want to figure out what's happening around our vertical asymptote at the -11. So the reason why I put the values on the chart is because we're going to look around that -11, but we want to make sure that we pick our test points close enough to -11 so it doesn't get interfered by the other vertical asymptote or the other x-intercept. So I'm going to pick my test points as -12 and -10 to see what's happening around that vertical asymptote. So if I let x equal -12 and substitute it into my function, -12 plus 7 over -12 times -12 plus 11, I'm going to get a negative over a negative times a negative, which is a negative over a positive, and get a negative there. So what that indicates to me is that on the left side of this vertical asymptote, our y is going to be approaching -infinity. So just to give a little bit more clear picture of what's happening, when we draw our graph at -11, our graph will approach -infinity on the left-hand side. So then my other test point was -10. So I substitute that into my function, -10 plus 7 over -10 times -10 plus 11. That would be a negative over a negative times a positive. It's a negative over a negative, which is a positive. So on the right side, our graph is going to approach positive infinity. So for the vertical asymptote of -11, the y is going to approach negative infinity on one side and positive infinity on the other side. Now let's do the same thing for our other vertical asymptote at 0. So I want to make sure that I choose test points around that vertical asymptote. So I'll choose -1 and +1. And we'll substitute those values into our function. And for x equals +1, I have 1 plus 7 over 1 times 1 plus 11. That's a positive over a positive times a positive. It's a positive over a positive, which is a positive infinity. So on the right-hand side of that vertical asymptote, at 0, it's going to go to positive infinity. And then on the left-hand side, for x equals -1, we get -1 plus 7, for -1 times -1 plus 11. That is a positive over a negative times a positive. It's a positive over a negative, which is a negative infinity. So on the left-hand side of that vertical asymptote, we have the y approaching negative infinity. So for this one, it's going to approach infinity on one side, negative infinity on the other side of both of our asymptotes. So we're going to put in -11 and 0. So next we're going to focus on finding horizontal and oblique asymptotes. And down here I put some instructions on finding horizontal and oblique asymptotes. What you need to know is that your numerator and denominator are polynomial functions. And because they're polynomial functions, the degree of the numerator and degree of the denominator are indicated by the highest power on those variables. And we're going to use those degrees. The degree of the numerator is n. The degree of the denominator is m. We're going to use those degrees to compare in these different cases here. So we have 4 different cases to deal with. When the degree of the numerator is less than the degree of the denominator, we have a horizontal asymptote along the x-axis, or the line y equals 0. If the degree of the numerator is the same as the degree of the denominator, then we're going to use the ratio of the leading coefficients. That's this a sub n and b sub m. Those are the leading coefficients up here, a sub n and b sub n. The ratio of those leading coefficients is going to be a horizontal asymptote. If the degree of the numerator is 1 more than the degree of the denominator, then we're going to have an oblique asymptote instead of a horizontal asymptote. And if the degree of the numerator is 2 or more larger than the degree of the denominator, then we're not going to have a horizontal or an oblique asymptote. So if we look at our example is r of x is equal to x plus 7 over x times x plus 11. And our numerator has a degree of 1. And if we were to multiply out, our denominator would be x squared plus 11x. Our denominator has a degree of 2. I'm using that highest power on x to indicate the degree. So since the degree of my numerator is less than the degree of my denominator, that puts me in this first case, where my horizontal asymptote is the line y equals 0. So the line y equals 0 is our horizontal asymptote. The next part, we want to determine any points where the graph intersects that horizontal asymptote. We just came up with a horizontal asymptote of y equals 0. So what we're going to do is we're going to take our rational function, r of x equals x plus 7 over x times x plus 11, and we said the horizontal asymptote is y equals 0, and we want to see where this graph intersects our horizontal asymptote. So since we're looking for where they're going to intersect, we can set them equal to each other to find any points where they intersect each other. So I'm taking my function and setting it equal to my horizontal asymptote, and I'm going to solve. If I solve, I would multiply both sides by the denominator. It would cancel out, leaving me with x plus 7 on the left. On the right, when I multiply by that denominator, it multiplies by 0, giving me 0. And I solve and I get x equals 7. So the graph is going to intersect the horizontal asymptote at x equals -7. So I would indicate here that the graph intersects the horizontal asymptote at x equals -7. To graph r of x using the graphing utility, determine the appropriate viewing window necessary to obtain the complete graph. Choose the correct answer below. So first of all, I just want to refresh myself on a couple things. My function is x plus 7 over x times x plus 11. We found that this function has vertical asymptotes at x equals 0 and x equals -11. It has an x-intercept at x equals -7. It has a horizontal asymptote at y equals 0. So these are some of the things I want to keep in mind when I'm deciding my viewing window. So first I'm going to start by eliminating these two choices here. So these two choices have an x-min of -20 and an x-max of 0, or an x-min of 0 and x-max of 20. So I'm eliminating those choices because when I think about my x scale for this graph, I'm going to have horizontal asymptotes at vertical asymptotes at -11 and 0, and that x-intercept at -7. So if I restricted my x-min to going from -20 to 0, then I would be missing out on this interesting section of the graph to the right of that vertical asymptote. And if I let my scale go from 0 to +20, then I'd be missing out on this vertical asymptote and this x-intercept. So you want to make sure that your interesting features like your vertical asymptotes and your x-intercepts are within that x-min and x-max. So let's eliminate these choices. So I kept the other two choices because they have an x-min from -20 to 20, and that would contain all of the vertical asymptotes and x-intercepts. So then let's decide between the y scale. So this y scale goes from -4 to 4, and this y scale goes from 0 to 4. So our horizontal asymptote is at 0. So for our y scale, we want to make sure that we have some of our picture above and below that horizontal asymptote so that we can see both sides of that horizontal asymptote. And if we chose from 0 to 4, we would be leaving off the bottom half of that horizontal asymptote. So we want to choose this first option of -20 to 20 for the x scale and -4 to 4 for the y scale. So finally, let's take a look at the graph of this function. I'm going to draw by hand and I'll show you with the calculator. We found vertical asymptotes at -11 and at 0. Maybe I'll draw those with a red. And then we had a horizontal asymptote at y equals 0, vertical asymptote at x equals 0, and a vertical asymptote at x equals -11. We had an x-intercept at -7, and earlier we indicated what was happening around those vertical asymptotes, that we would go to -infinity on one side and +infinity on the other, -infinity on one side and +infinity on the other. And then as we look at our end behavior, we're approaching that horizontal asymptote. So that looks like this picture here. Now let's take a look with the graphing calculator. So with my calculator, I'm going to type the function in the y equals menu, making sure I put parentheses around the numerator and denominator. I've got parentheses around my numerator of x plus 1, parentheses around my denominator of x times x plus 11. I'm going to go to my window and make sure it matches -20 to 20, an x scale of 2, and from -4 to 4, and take a look at that graph. So you can see our picture. Our picture shows the vertical asymptote at -11, the graph crossing the x-axis at -7, and the vertical asymptote at 0. Thank you for checking out my videos. Have a great day.